Hello everyone. Today we will discuss current electricity part. Before this we studied electrostate in which electric charge is at rest position, but now when the charge particle is in motion. First we talk about electric current in current electricity part. Consider there is a conductor. Example, it is a piece of any metal wire, example copper wire. If we connect a battery with this is positive terminal and this is negative terminal. As we know, this is a source of electron. The positive terminal attract electrons. The flow of electrons, the direction of flow of electrons is negative to positive direction. Here, in the conductor, the flow of electron in this direction. Current electricity, the net amount of these charges passing through this cross-section area per unit time is known as current electricity. The net amount of charges passing through the cross-section area per unit time is electric current. It is denoted by I. It is a scalar quantity. Unit, because we know it is a fundamental unit, fundamental quantity, so SI unit of this quantity is ampere. If we talk about the formula of electric current, I, as the definition, the net amount of charge, we consider the net amount of charge is Q, the time is T, then I is equal to Q upon T. This is the formula of electric current, and from here the unit is also written as, we know the unit of charge is coulomb and the unit of time is second. So coulomb upon second is also we can write a unit for this quantity. So this is the concept of electric current. If we talk about the direction of the electric current is opposite to flow of electrons, or we can say in the direction of flow of positive charge. If we talk about a circuit, in a circuit, what is the direction of electric current? We know this is a low potential and the positive terminal is at high potential. So the direction of electric current, high potential to low potential. So this is the direction of electric current in a circuit. High potential to low potential. Further, if in different time interval the amount of charge is different passing through the cross section, then we can calculate average current for this metal or for this conductor. So if we talk about average current, if the net charge is delta Q, in different time like Q1, Q2, Q3 and so on, but we consider that the net charge is delta Q and the time interval T1 plus T2 plus T3 and the total time is T. So delta Q. Then the average current is total charge upon total time. Thus we can calculate average current. But if we find the value of current at any instant, then the current is known as instantaneous current. If this delta t tends to 0 means the time interval tends to 0 means for the instant we want to calculate the current, then the limit delta t tends to 0, then delta becomes d, then I is equal to dq upon dt. This is instantaneous current. So this is the concept of electric current. First we will discuss what is electric current, the formula, the unit, the quantity is a scalar quantity, and the direction, average current and instantaneous current. If in question given the value of electric current, but we have to find out what is the value of charge, then we can calculate by using this formula. What if current is given, then charge. We know from this, from equation A, dq is equal to I dt. If we integrate this, then the total charge is q, 0 to t time I dt. By using this formula, we can calculate total charge if the value of electric current is given in any equations. Now, in your mind, there is a equation that if the quantity have direction, then why it is a scalar quantity. Question: why electric current is a scalar quantity even it has direction? For this, we discuss an example. Consider there is a wire in which 3 ampere current is flowing. There is also another wire in which 4 ampere current is flowing, and there is another wire connected with these two wires in which we have to calculate electric current. If we find out the electric current by using vector addition rule. By vector addition rule, if these two wires mutually perpendicular, then what is the value of electric current? I, because I is the resultant of these two wires. I is the resultant quantity of these two directional quantity. So the resultant formula is a square plus b square, so 3 square plus 4 square plus 2ab cos phi. Cos phi in cos 90. Cos phi means cos 90. Cos 90 is 0. So this value is 0. So the electric current by vector addition rule is I is equal to 9 plus 16, 25, which is equal to 5 ampere. But we find that the electric current's value is directly we can add these values. 3 plus 4 is 7 ampere. So this value is wrong. So for any vector quantity, the quantity must follow vector addition rule. Then the quantity is known as vector quantity. But the current does not follow vector addition rule, so it is a scalar quantity even it has direction. Okay, I hope the concept is clear. It does not follow vector addition rule, so it is a scalar quantity even it has direction. It can be calculated by algebraic sum of all current values. Means algebraic sum is example. There is the direction of current at this point is inward, so the sign of this value is we take positive, and this wire also the direction of electric current is inward, so this value also positive. But if there is another wire like this, if the value of current in this wire is outgoing like 2 ampere, then what is the value of I? Then we can calculate it. Inward direction plus 3, inward direction plus 4, and from here this is outward direction, so minus 2. Then the value of 7 minus 2, 5 ampere. Means we can calculate directly by algebraic sum of these current values. Okay. Now we will discuss about the current density. Yeah, we can relate mass density for this quantity also, like that the mass per unit volume for any quantity is known as mass density, as here the current density. Example, there is a conductor which have variable cross section area and it is connected with a battery. Okay, the direction of electric current is positive to negative terminal. The net amount of electric current passing through this cross section area per unit area. The value of the net amount of electric current per unit area is known as current density. It is denoted by J. It is a scalar quantity. If we talk about unit, from the definition of current density, the current density J is equal to the total amount of electric current. Consider this is delta I and per unit area, so we consider this is delta A. Then the formula of current density is J is equal to delta I upon delta A. From here we know the unit of this ampere. The unit of area is meter square. So the unit of current density is ampere upon meter square. From here we also find out the dimension formula of this. What is the dimension formula? The value of Kg 0, so m0 meter square in a cone. So there is L minus 2 time 0 ampere A1. This is the dimensional formula of this quantity. If the conductor have constant, or we can say uniform cross sectional area, then what is the value of J? For uniform cross section area, J is equal to the net amount of current is I and the uniform area is A. Then J is equal to I upon A. This is for uniform and this is for non-uniform. For non-uniform, the value of J is variable. For uniform, the value of J is a constant. So this is the concept of a current density. Okay, next. Now we talk about the motion of electrons in a conductor. If the conductor is not connected to a battery, means there is no external electric field. Without electric field, some of free electrons moves in this direction. Then in this conductor there is another electron also present which is moving in the opposite direction of this electron. For example, this is the electron which is moving in this direction, and more, if this electron is moving in this direction, then there is another electron also which is moving in this direction. Okay, in a conductor, the electric charge means the electrons collides with each other, and the path of electrons is always a straight line. Okay, now we can say, if we talk about the average velocity of the electron, if we consider the velocity of this electron is v, then the velocity of this electron is also v, and they cancel each other's effect by colliding. Then the average velocity of electron is 0 in a conductor without any source, without any external electric field. Okay. Now we will discuss mean free path. First we discuss free path. If we talk about only any electron, one of the electron, the distance between two successive collision of any electron is known as free path. But what is the mean free path? Here the mean is for the average value of the all electrons which is present in the conductor. Now another term, mean relaxation time. What is mean relaxation time? If we talk about a single electron, then relaxation time, the time taken between two successive collision, the time is known as relaxation time. If we discuss the average value of all the electrons, then we use mean relaxation time like this. So these terms we must know for any conductor. Now we will discuss if this conductor is connected with a battery, or we can say if we apply an external electric field, then what happens? This is the conductor. We connect a battery with this. This area behave as positive charge plate, and this plate is this area is behaved as a negative charge plate. From these plates, there is an external electric field produced in this direction, positive to negative direction. As we know, electrons have a negative charge, which is attracted by positive charge. So the electron is attracted by this positive area, or cross-section area, you can say positive plate. So all of the three electrons align with the opposite direction of the external electric field. Now we discuss the path of a free electron when the external electric field is applied. Without external electric field, if one of the electron is moving like this, example, any of the electron is moving like this. If we applied external electric field, then what happens? Then the electron is attracted by the positive charge plate. Mean example, this is positive terminal and this is the negative terminal, and the electron behave now change some. The electron is attracted to the positive terminal somehow. Then the path of this is become like this. If I draw here, if this point is A and this point is different, this point is B. If this point is A, this point is B without external electric field, but when we applied the external electric field, then the position of the electron is changed like A prime to B prime. This is the behavior of motion of electron without electric field and with the external electric field. Okay. I hope you understand. Now we talk about another term, drift velocity. What is drift velocity? When we applied some external electric field, then electrons attracted to positive terminal. Then we can say the electrons some shifted to the opposite direction of the electric field. The shift is not in very large, but the current produced by this shift is in very large amount, and the velocity of the electron to shift opposite of the electric field is known as drift velocity. Okay, drift velocity. If we apply some external electric field E, then free electrons shifted in opposite direction of E, the velocity in opposite direction of the velocity of electrons in opposite direction of E is known as drift velocity. Now we derive the formula of drift velocity. We applying external electric field, the final velocity of electrons is V equal to u plus at by equation of motion. If we take expectation value or average value of this, then average value V, average value of u plus average value of T, because A is constant, so we cannot take the average value of A is A. Okay. We apply external field, and the force is Q. Here Q is charge of electron. Now F is equal to m. There is a charge, the force is attractive, so the negative comes here. Here from here the acceleration is minus E upon, and we use this term in this formula. Okay. Now this V equal to, thus this value is initial average velocity without external field. We can say this is the value of average velocity without external field. We know without external field the average velocity of free electrons is 0. So this value becomes 0, and the value of A from here minus E upon m, and the average value of T is known as mean relaxation time, which is denoted by tau. So, and the final average velocity is drift velocity equal to minus E tau by L. This is the drift velocity, and this is the vector from drift velocity. This negative shows that the drift velocity is in the opposite direction of applied electric field. Okay, we must know this formula, which is very important. Now we further discuss the relation between electric current I, drift velocity Vd, and current density J. If there is a conductor, the length of this conductor is L, and the cross-section area is A. So the density of this conductor is N means number of electrons, free electrons per unit volume. Then total number of electrons in conductor, N equal to N, the total volume is V, and what is the volume of this conductor is A into L. Now the total charge Q is equal to Ne. Then what is the value of Q is NaLe. We know electric current is equal to Q upon T. The value of Q is NaLe upon T. NeAL upon T means the flow of the velocity of the electrons from this point to this point. Okay, L upon T, which is known as drift velocity. This is the relation between I and Vd. Now we know current density. Now we know current density J is equal to I upon A. I value of I is equal to NeAV upon A. So the value of J is equal to NeAV. This is the value of current density. This is the relation between J and V. Okay, now we will discuss some PYQs. You can see here the question. The question is a flow of 10⁻⁷ electrons per second in a conductor wire contributes a current of means we have given the number of electric charge and we have to find out the value of electric current. How can we solve it? Given N, the number of electrons, 10 raised to power 7, and we know the value of Q is equal to Ne, and 10 raised to 7, E value 1.6, 10 raised to power minus 19. If we simplify it, then the value becomes 1.6, 10 raised to power minus 19 plus 7, minus 12 coulomb. And we know I is equal to Q upon T. So the value of Q 1.6, 10 raised to power minus 12, T given second. First second means T equal 1 second. So the value of 1.6, 10 raised to power minus 12 ampere. So the option A is correct. Okay. Now copper wire of radius 1 mm contains 10 raised to power 22 free electrons per cubic meter. The drift velocity for the free electrons when 10 ampere current flows through the wire will be. So we have to find out the drift velocity as we derive we know the relation I is equal to NEAVD. If current is given and we have to find out the value of drift velocity, we can use this relation. Okay, now put the values which are given. The number of N is equal to 10 raised to power 22. I, the value of I is 10 ampere, and the value of cross section area A 1 mm radius given. So we have given the radius of cross section area 1 mm. Okay. 1 mm. So the 1 mm 1 into 10 raised to power minus 3 meter. So the area pi r square pi r square 10 raised to power minus 3 per square. So 10 raised to power minus 3 square, 10 raised to power minus 6 pi meter square. Now the value of drift velocity is I upon NEA. The value of I 10, the value of N 10 raised to power 22, the value of E 1.6, 10 raised to power minus 19, the value of A 10 raised to power minus 6 pi. So it becomes, if we simplify, minus 19 minus 6 minus 25 plus 22 minus 3 and minus 3. If we put here, then it becomes plus 3. The value here 1.6 pi. This becomes 10 raised to power 4 1.6 pi. 6.25 in this. Value becomes if we take here 10 raised to power 3, okay, then 100 into 10 raised to power 2 and 1.6 into pi. If we solve here the point, then the 10 is here 60. If we divide 100 by 60, then it gives value 6.25. As options are given, approximately 6.25 into 10 raised to power 3 upon pi. So we match the value with the options. Okay, the option B is correct. Okay, B. And next PYQ, you can see here the question is the electric current through a wire varies with time as I is equal to I naught, given I is equal to I naught plus beta t, okay, plus beta t, and where I naught is ampere and beta is ampere, naught is equal to 20 ampere and beta is equal to 3 ampere per second. the amount of electric charge crossed through a section of a wire in 20 seconds, and we have given time interval 20 seconds, and we have to find out the value of a charge in coulomb. We know the value of electric current, the formula of electric current is dq upon dt. From here, dq is equal to I dt. If we integral, then the value of charge is equal to integration I dt. Here we have given time interval 0 to 20 seconds. So 0 to 20, if we integrate this, and the value of I is equal to I naught plus beta t dt. We solve it. Here I naught t plus, if we integrate this, beta constant, the integration of t is equal to, and the limit is 0 to 20. Now the value is 20 into the value of 20, the value of t is upper limit minus lower limit, 20 minus 0, meaning plus the value of beta is 3 into beta 2 is here, and t square. 20 square minus 0 is 20 square, 20 square is 400. If we simplify it, 200 and 400 plus 3 to the 600, and the value of this is becomes 1000 coulomb. This is the value of total charge in 20 seconds. The option B is correct. Okay.
There are some PYQs. Practice yourself. Okay, thank you.